show z such that the argument of z plus 4 minus 2i equals pi over 3 on an Argand diagram. Now we're going to use the following principle. So with this principle, if we assume that a and b is positive, it's just to get the rule, then we can do the following. We know that this is a translation of a normal Argand diagram, so of a normal ray. So what we do is we say that it's translated not in plus a, but in the inverse of, not the inverse, in the opposite, which is minus a. So the real value will, instead of starting there, will make an, so instead of having the normal one there, where this is theta, it will now move to negative a, so the real value will move to negative a, and the imaginary number will move to negative b. So this is the imaginary value that will go to negative b, so it will move to a new position, let's say there. That point there will be, my real value will be minus a, and my imaginary number will be minus bi. The angle will still be the same, so that angle that we have there will still be theta, and that is how that one translates. So let's look at this example then. To draw this, I'm going to have my Argand diagram. My new translation is going to be the real value, so this is my real value, this is my imaginary value. My real value is going to move to negative 4, so roughly 1, 2, 3, negative 4, and this is going to move to negative 2i, which means it becomes plus 2i. So this point will move to negative 4 plus 2. I will put in what that point is there. This is 2, and this will be negative 4. And then the angle that it makes with my x-axis, positive x-axis, is pi over 3, which is roughly, so remember, if it was over here, this would be pi over 3, which is 60 degrees. So my graph will be from there. That will be my ray, and the angle there will be pi over 3.